Now, process reengineering, the textbook definition is that this is a fundamental rethinking and radical redesign of processes to improve performance dramatically in terms of cost, quality, service, and speed. Okay. And typically, when you think about this, think about it in light of the fact that we live today in a very competitive landscape. Okay. And organizations are typically constantly striving to improve their efficiency, reduce waste within the production processes, and also possibly enhance customer satisfaction, knowing that a happy customer is a customer who can potentially become a return customer. Okay. And as we're looking at the different approaches to process reengineering and continuous improvement, let's keep in mind those three aspects. How do we improve efficiency? How do we reduce waste? And how do we enhance customer satisfaction? Okay. So what we're going to be looking at in this video will be what are some approaches that have been used by companies, that are continuing to be used by companies to make their systems better, with their overall objective of improving efficiency, increasing customer satisfaction, and eventually resulting in a higher level of profitability and a higher quality of product or service being offered. Okay. Now, for a company interested in process reengineering, a couple of elements that they typically want to focus upon. Okay. One is, as you're going through the process of engineering, you're not going to be trying to re-engineer each and every single process, right? The resources sometimes might not be there to do that. Sometimes there's no need to improve certain processes. So rather than trying to change everything at the same time, your typical process engineering might focus on what processes are critical to success or critical to the achievement of a company's competitive priorities, okay? And which processes would have the highest net impact towards whatever the company's objectives would be, okay? And once a company figures out what those processes are, then they might want to focus on, okay, how can we go about trying to improve those specific processes, okay? Now, obviously, given that any process reengineering process involves capital, it typically would require your company to have the company's leadership involved. The company's leadership typically should enable the company's employees to have buy-in. If the leaders consent to any process reengineering, it becomes easier to be able to approve a team of people getting together and trying to figure out a better way to approach any given process, okay? Your typical process reengineering will involve multiple teams, people from different departments, from industrial engineering to operations management, to accounting and finance, to human resources management, to sales and marketing. All these people provide a different perspective on what the organization is about. And typically having such cross-functional teams really adds a lot of value, because their perspective on what drives company success typically differ, or might have a different perspective, but when you bring them together, it brings for more wholesome reengineering experience, okay? A lot of processing reengineering activities will involve the use of information technology systems. And that's something that we emphasize a lot in any process reengineering process. The clean slate philosophy focuses on coming to the table with an open mind and a willingness to understand a process from scratch and to try and figure out a better way of enabling a given process, okay? So one thing that you'll find with a lot of organizations is that people are used to doing things a certain way, and enabling change typically involves trying to break somebody from a mold or from a way of doing things that they've gotten used to, okay? So the clean slate philosophy says that we have to think outside our molds or different buckets that we're typically used to doing things, and be open to the idea of being able to do things a slightly different way. Okay. And that then should lead to a more positive outcome. Okay. So when you talk of process improvement, we're looking at a way to systematically review the different activities or different processes that a given company has, and then to seek to find ways to make them better, to make them more efficient, to make them more effective. Okay. And the one approach that I'm going to be looking at is going to be, we're going to start off by looking at something called the DMAIC, I call it the DMAIC process improvement model. Okay. And this is a 5-step model. Okay. And this model here starts off with what's called the define phase, moves on to the measure phase, analyzing the analysis phase, an improvement phase, and finally to a control phase. Okay. Now, each and every one of these buckets here, even though it's simplified to this extent, is each stage here is pretty extensive. The number of different tools available to the organization at each and every one of these stages here is immense. Okay. And for companies that engage in a Six Sigma process improvement model similar to this, the outcomes have typically been quite positive, and that's why it's continued to be a model that's emphasized as a way of trying to improve a process or a given set of processes. Okay, so let's look at each and every one of these individually. Okay, because as I mentioned, there are 5 distinct phases here, starting with the define phase and going all the way down to the control phase. Okay, so if I start with the define phase, and I'll also look at some of the different tools available to you and to the corporation that wants to engage in a process improvement activity. Okay. So for the define phase, this is a phase where we outline the scope, the boundaries of the process. Okay. It's the initial phase. And this is a part where the team that is put together has to clearly define what's the problem being faced or the issue being faced, or possibly if not even an issue, it could be just an opportunity. Okay. That exists for some kind of improvement. Okay. It's during this phase that the team, the cross-functional team, gathers information to try and better understand the current state of that process. Okay. And there'll be a bunch of questions that they would have to answer at this stage. Who are the customers impacted by this? Those customers could either be internal customers, employees of the organization, or external customers who the company sells products or services to. Okay. The team would have to also at this stage select what specific process or project to engage in. Okay. And typically it's going to be based off of what has the highest impact. Okay. So that's something that would have to be analyzed and defined by them. And typically the best way of understanding what has the highest impact is you're going to have to quantify that. So you don't just look around and see we have 10 different processes. For you to justify your process as a project or a process worth reviewing, I think it's important for you to justify that in terms of some quantitative metrics. Okay, so that is something that the project team might want to at this first define phase figure that out. Okay. It's also this phase that they'll develop a problem statement, different documents that might be needed that will outline what will be done over the phase of this improvement process. Okay. There are different tools that I'll look into, and maybe let's go ahead and look at some of those tools. Okay. And things that would have to be done. Okay. So some of the things that you typically might engage in at this phase would be to come up with a project scope. Okay. And the project scope will outline what should be included in that project and what lies outside the boundaries of the project. Okay. Project charter is also a type of a guiding document that outlines what's going to guide the project team as they go about trying to improve a given process. The business impact statement would be where you try and summarize what the expected outcome of the project is going to be to the different stakeholders involved. Okay, so there are a bunch of different tools, and I'm going to go through some of them right here. Okay, sorry. Again, the business impact statement throws light on critical business processes and identifies which business units, operations, and processes are vital for the organization's existence. If you look at the voice of the customer, this speaks to the fact that as we are trying to improve a process, the person who this process improvement impact plays a pretty critical role. So it's important to try and get some input from that customer, be it an internal customer or an external customer, okay? So the voice, the expectations, the preferences, any comments they might have about a given product, process, or service should be something that is incorporated at the defined stage, okay? The different other tools that I typically would not go into in this class, but if you're to go take it a step further and go to a Six Sigma or a Lean Six Sigma class, then you might go into greater depth into these different tools. Okay. I think I had a sample project charter which looks something like this with different sections. What's the project title? What are the core team members? What's the key stakeholders here? What's the actual business need? What's the objectives of the project? What are the different goals? And what are the different milestones? So this kind of like summarizes what's expected to be done over the course of the entire project. And at the very bottom, we have the expected deliverables in the different time frames. Okay. This project scope, again, talks about what will be a part of the project, when do we expect to start, and when do we expect to end the project, all the different sub-processes that might be linked to the process under consideration, what product lines would be impacted, where or which locations would be impacted, things like that I would define the project scope. Okay. Now, the second phase, the second step that we look at in the DMAIC process is the measure phase. And in the measure phase, we're typically seeking to figure out how to quantify, first of all, the current performance of a given process. How well is it doing currently? Okay. It's at this phase that we start looking at data collection. Let's go into the plant, collect data on the given process. How well is the current process doing? Okay. And then at this stage, if you look here on the screen here, there are a bunch of different tools available to the team that's going to be engaged in this process improvement. Okay. So they'll collect baseline data, put together the metrics that I think are most important for whatever the type of project they're engaged in, right? And metrics could be related to quality targets. It could be related to things like cycle time, could be related to the cost of manufacturing, could be related to things like how satisfied are the customers with what we have, okay? So at this stage, what we map out the current process. It's at the stage that we collect data on the current process. It's at this stage that we try and identify any potential root causes of any variants that might exist in the system, okay? It's at this stage that we use things like an Ishikawa or a fishbone diagram to try and drill down to the root causes of the problem that might be resulting in whatever outcomes are currently being experienced, okay? Now, once we pass the measure phase, we move on to the analyze phase. And this phase here typically involves diving deep into whatever data was collected and then trying to use that data to identify root causes of the problem, right? So you're trying to analyze the situation as is with the hope that once we know the situation as is, what then can we do to make it better, okay? So there are very many tools here as well to be able to try and analyze data. And typically we might want to do possibly identify is there any forms of waste in the process, okay? Later on in this course, we'll might touch on what's called value stream mapping. That could be a tool that could be used to try and figure out is any waste within the process. It's at this stage too that I might want to incorporate what's called a Pareto chart. A Pareto chart would just basically tell me what are, and actually, I'll skip that because I'm going to discuss this at a later point in this specific video, okay? The root cause analysis approaches might be used at this stage. There's ANOVA, analysis of variance. The different tools that I might want to engage with to try and better analyze the data that was collected in the previous measure phase, okay? And once we've analyzed the data, then we move on to stage 4. And in stage 4, since we have some insights into what might be the root cause of the issues being faced, we're now looking at this phase to try and develop or implement solutions to try and address these root causes, whatever issues we determined in stage 3. Okay. So at this stage, the team might decide to brainstorm different solutions, and we have tools to help them with that. And there are, again, a whole bunch of different tools that your typical Six Sigma process improvement team might use to try and figure out what are the different ways we can actually improve a given process, okay? So after the brainstorming, after the settlement on a given approach, sometimes they might decide to develop maybe a pilot test to just test to see if we go a certain way to trying to improve this, does it actually result in a process improvement, or does it result in the same outcome, or does it even result in a worse outcome, okay? And on the basis of that pilot test, it's possible that you can now develop a full implementation plan, plus maybe some kind of a roadmap to implement whatever solution that the team puts together. Okay. Now, in the final part to this, we have the control phase. Okay. And just so you know, in chapter 3, we'll be looking at statistical process control. Okay. Where we try and see how well is a given process operating. Is it conforming to certain given stipulations or targets? Okay. So this final phase, again, focuses on trying to ensure that whatever improvements have been put in place in stage 4 are sustainable. Okay. Because you don't want to have an improvement put in place and then after a few weeks or a few months, we drop back or regress back to what we previously had. Okay. So the team will at this stage monitor the process, try to verify that the changes that have been put in place are effective, and that they continue to deliver the value that they initially expected them to deliver. Okay. So it's at this phase where the team will have to determine what type of control plans to put in place. Okay. Should we use SPC approaches and the different types of things that an SPC analysis would do? Okay. It's at this phase too that the team will have to figure out how can we standardize our processes and ensure that it continues to be effected the same way over and over and over again. And one of the tools that they would use at this stage could be to use standard operating procedures. Okay. Once you document your standard operating procedures, it makes it easier for any employee, whether it's a new employee or an employee already working in the department, to know what's expected in terms of how that process should be handled. Okay. Now, keep in mind that as we are using the DMAIC approach, this is it's not something that's static. Okay. Once we reach the control phase and we've implemented these improvements, it's not linear. It's almost like circular because it's something that we move on to the next project, then the next project, then the next project. So it's a continuous improvement. And the teams might differ, but the overall outcome is that over time, your corporation is moving towards trying to get to 100% efficiency, right? We never really get to 100%, but with each and every project, we hope to get closer to 100% in terms of what we do. Okay. So the benefits of trying to do this would be, again, can we improve the efficiency of the organization in terms of how its processes are managed and run? Okay. Typically, if we've eliminated any waste, if we streamline the processes to make them more efficient, you should witness some gains to the system as a whole. Okay. A number of Six Sigma process improvement projects focus on the quality of the product or service offered. So the root cause analysis should enable you to determine what needs to be tackled first, what has the greatest impact, and overall should result in some improved quality. Okay. And as we improve efficiency, improve the quality, another benefit would be we should notice a reduction in cost, hopefully, right? Either through learning processes or things like that, but eliminating waste, increased learning by employees typically translate to some cost savings. Okay. Now, let's look at some of these tools that we talked about in slightly more depth. Okay. There's some visual tools. I love visual tools because visual tools tell a story almost without having to explain what's being talked about. Okay. And your visuals typically the fastest way to convey information about a given process. Okay. Let's look at the flow charts and then we'll look at the other tools that we have here. Okay. So a flow chart is basically a diagram. It shows you how a given process operates from scratch to finish, right? And it could show you how employees handle stuff, who handles what. It could show how information moves through the system, either downstream or upstream, okay? And it conveys a certain amount of information, right? So if I was defining or measuring information, I might want to start off by having a flow chart of the system as is, because it provides me with a visual of what we currently do. Okay, let's look at a flow chart here. And let's look at a swim lane flow chart. Okay. When you talk of swim lane flow chart, it's just a flow chart that also incorporates information on which specific department does what. Okay. Now, if I look at this swim lane flow chart that we have here, it has five different departments or five different groups of people or stakeholders involved. Okay, there's a customer, there's a sales department, the operation or production department, the finance department, and marketing. Okay. And just by looking at this, I see that this has to do with the customer placing an order and potentially what happens after the customer places an order. Okay. So I see here the customer submits his order. That translates into a request for quotations. The sales department receives that order, prepares that quotation, and submits that quotation back to the customer. If the customer deems it acceptable, then they might proceed and have a valid order. If not, there might be some modifications and things like that. Okay, but it typically gives me a visual of what happens from the time one activity triggers off a whole bunch of other activities to when we finally terminate that specific process. Okay. Now, the beauty of having a visual is that if I'm trying to figure out where an issue might arise, okay, I'm able to visually see what each and every department does, where there's a potential loss or waste, or where there's a potential for cost saving or time saving. This is a pretty useful tool. Okay. So the other tools that we have, for example, time studies. And time studies are typically used to try and measure how well a company's employees operate or perform a given process, right? If you're not able to capture how well your employees operate over the course of any given day, you might not be able to set targets and goals. So your typical time study or work measurement technique enables you to better understand the process flow as well as how much time a given product or process should take to get through from beginning to the end. Okay, let's look at an example of a work study or a time study. Okay, a process at a watch assembly plant has changed. the process is divided into 3 work elements. A time study has been performed with the following results. And I have that table on the next slide. Okay. The time study for the process previously was 14.5 minutes. Based on the new time study, should the time standard be revised? Okay, so let's look at the data. Okay, so I have 3 different elements that go into this specific activity, 1, 2, and 3. And somebody has to manually go into the plant or the workspace and observe the employees or whoever it is who's actually making those watches, how much time it takes for them to put those different components together, right? So what I see here is that an employee, the person tasked with doing this time study went to the plant and took 4 different samples. Observation 1 is the first sample. Let's assume that all the 4 samples were taken in one day. It could be that observation 1 was taken at 8 in the morning. 2 could have been at maybe 10 in the morning. 3 could have been at 12. Observation 4 could have been at 2 in the afternoon, something like that. Okay. Now, for each and every activity that's done, could be different people, it could be the same person. We possibly take a stopwatch, figure out how much time it takes, and then we calculate for each and every element, what's the average across these 4 observations? What is the average amount of time taken by this person or by this whoever's tasked with this element? Okay. And that gives us a starting point for this specific element of work. Okay. Now, the fact that my average time is 2.73 minutes for element 1 does not mean that that's the amount of time that that specific time activity should take. It could be that this employee is pretty slow. Okay. And if this employee is slow, then I don't want to use his time as my target time for this specific element of work. Okay. Or it could be that the employee is really fast, faster than the average employee. And if that's the case, trying to have everybody meet the pace of somebody who's extremely fast might not be logical or practical. Okay. So our second to last row here, which has the RF, is a performance rating factor. Okay. And this helps us adjust the average time that we have here to give us what's called the normal time for that specific work element. Okay. Now, if you get a performance, if you have a performance rating factor of 1, it means that the average time that we witness here is, in the opinion of the person who's doing this assessment, the average amount of time that should be taken for that specific work element. Okay. So your normal time here equals your average time multiplied by your performance rating factor. Okay. So you'll notice with this first element here, the average time was 2.73. The performance rating is a 1. Okay. And if I multiply those two, my normal time stays at 2.73. Okay. So that tells me that whoever conducted that work element conducted it in a timely manner, in the manner that the time that we expect that specific element to be completed in. Okay. Now let's look at the second element. If you get the average of these 4 observations, I get a 4.875. Okay. But if I look at the performance rating factor assessed here, that's a 1.1. And when you multiply the average time by the performance rating factor, you get a normal time that's slightly higher. Okay. This person here was somebody that I believe works faster than the average. And the performance rating factor here reflects that he's working at, it's almost like, if I was to put this in layman's terms, this person is working at 110% the speed of your average employee. Okay, so he's faster than the average employee. So the normal time here tries to give the average employee slightly more time to finish that specific work element. Okay. And for the last element, element 3, the average time here multiplied by the performance rating factor of 0.9 results in a normal time of 1.9. Okay. That would be in a situation where your average time here, observed average time, is believed to be slower than what the normal time should be for that specific element. Okay, so by using a performance rating factor below 1, we get a normal time, kind of like our target time, which is lower than that which was observed across these 4 observations here. Okay. Now, so if we if we add all these up, we end up with our total normal time, 2.73 plus 5.363 plus 1.922 equals our total normal time of approximately 10 minutes. Okay. So that would be what goes into a time study. Okay, there's still one extra step, which is to calculate what's called the standard time. Okay. And the standard time takes into consideration the fact that there might be a need for an allowance to that entire process, right? Allowances could be for a variety of factors. It could be just to give each employee just a bit more time. In layman terms, it could almost be, think about if you are working during the course of the workday, you might take a bathroom break and things like that. Okay. The same for the time study here. We typically are going to add a certain fraction of time to the total normal time as an allowance. Okay. And that then, if you multiply that, if you add that allowance to the normal time, you get your standard time. Okay. For this specific case, we were told that the allowance for the whole process is 18% of total normal time. So I know that my standard time will be the total normal time plus 18% of total normal time. Okay. And if I do that, I end up with what we call the standard normal time to assemble a given watch at this plant. Okay. So going back to the original question, okay, we're told here that process had changed. Okay. And the time study was conducted. Previously, it took this company 14.5 minutes to make one watch. With this new system, it now takes them 11.82 minutes per watch. Okay. So we can say that whatever process changes were made actually did result in a reduction in actual time. Okay. In some other settings, we'd have to maybe verify whether or not this reduction is statistically significant. But for the purposes of this class, if you are faced with such a question, you'd say that yes, this change to the process actually resulted in a reduction in total time associated with this given process. Okay, and you could do this in Excel. I have an Excel spreadsheet here with the exact same thing. Okay, in Excel, I'm interested in my normal time, and I'm also interested in my standard time. Okay, let me just make that standard time. And let's make this slightly bigger. Now, I could skip typing each and every one of these in and just go straight to my total normal time. Total normal time. Let's make this slightly bigger again. My font's small. So my total normal time here, I could use a function called sum product. Sum product. And my sum product function here is going to multiply my average times here, the 3 average times here, by the corresponding performance rating factors. Okay. And I get my total normal time as approximately 10.01 minutes. Okay. We were told that our standard time is going to have an addition of 18% of total normal time as an allowance. So for my standard time here, this would be my total normal time multiplied by 1.18. Okay. The 1 here represents the 100% for total normal time. The 0.18 here is the 18% of whatever the allowance was. Okay. So with that, we get our standard time as 11.82 minutes. Okay. So that's that. Now let's look at a few other tools available to you. Okay. Work sampling is a tool that can be used in situations where you're trying to figure out what's the proportion of time that your employees are actively engaged in working versus how much time are they idle over the course of any given day, right? And the logic behind this is that you don't want to have employees being overly idle because that's a form of waste. Okay. So a work sampling study can enable us to figure out, for example, if you look at the table we have here, um, again, this is by observation. The times that an employee was busy, maybe 6 hours, times or idle or 1 hour, or it could be based off of the number of observations. How many times did you go see the person being busy or something like that? Okay. And then you can use the proportion of idle time to try and figure out if that's acceptable, or should we consider process improvement that might reduce that portion of idle time. Okay. Learning curves are something that we might also be interested in, because if we have a certain system in place, the amount of time taken to produce a certain amount of output should over a period of time reduce at a reducing pace over time, right? An example I would give here would be if I had a brand new employee join a company, and the company was making maybe a sort of fast food restaurant, they're making burgers, right? The amount of burgers that this person might make on day one compared to the number of burgers that he could make on day 50 would be different, right? On day one, there's a lot more learning. There's a lot more, right? It's typically going to be slower, okay? And by the time you reach day 50, this person has flipped burgers and made burgers over and over. The amount of time it takes him to do that same exact activity will drop, okay? And as a result of the time dropping, the number of units produced, as we see here, goes up, okay? So if you look at what's on the y-axis here, the amount of hours per unit starts off high, but as we make more and more units, the amount of hours required per unit drops, and the number of units then go up. Okay, the employee becomes more efficient at what he does. Okay, and we typically would want to know that as something that can possibly drive any type of process improvement model that we might engage in. Okay, process charts. So process charts are a way of trying to document different activities performed within the course of any given workday, right? And if you look at different processes within a company, within a service-based business, they typically have any one of these five types of activities, right? Uh, an operation is an actual, what do you call it? An actual act by a person converting something from one state to another, right? For example, with the previous example of somebody working at a restaurant, a fast food restaurant, an operation here would be the production of a burger. Okay. A transportation involves the movement of product from one place to another, or the movement of a person from one place to another. Okay. An inspection typically linked to something like a quality inspection where you pause for a moment to check the quality of what's being made. Okay. And the times when the process or the system as a whole is delayed, and we might want to indicate where that would be. Okay. And then the last activity, you notice here that we have different icons for each activity. The downward facing triangle has to do with product that's being stored for use at a later stage of the process. Okay. So let's look at an example of what a process chart would look like and how you'd go about using a process chart to try and better understand a system. So the figure 2.1 in the textbook looks at a process chart for an emergency room admission. Okay. So we assume a patient pulls up or is brought to an emergency room and there are a couple of steps that that patient has to go through before exiting the system. Okay. And your typical process chart will have these columns here. Okay. The step number, the amount of time it takes for each and every step, the distance traveled, if any. Okay. And you'll notice in this fourth section here that we're going to try and figure out for each step description here. Is it an actual operation? Is it a transportation? Is it a delay? Is it a storage? Which one of these? Is it an inspection? Which one of these activities does that activity fall under? Okay. So if you look at the steps here, the first step is to enter the emergency room, approach the patient window. Okay. And I think of that, that is a movement from the door to the patient window. Okay. And so I would classify that under this arrow here and say that that was a transportation. Okay. You'll notice too that with each transportation, we'll have a distance moved and the amount of time it takes for that patient to do that. Okay. Then there's sitting down, filling out patient history. That's considered an operation. It's something that's being done. An actual activity is being done. So I would classify this under this circle here, the circle icon here. Okay. And as you go down all these here, you want to try and classify each and every step into one of these 5 buckets. And you end up with something that looks like this, okay, which tells you exactly where each and every one of these fall under, okay. And as a final step, you end up with a summary of each and every one of these different activities, right? So for this patient who was observed coming in, they went through 5 different operational steps. There were 9 different times when they moved or moved from one place to another. There were 2 different times when they were inspected by either a doctor or a nurse or some other kind of clinician. And then there were 3 instances of time when they were delayed. Okay, maybe filling out paperwork, sitting there waiting for somebody to take them to the next step. Okay. Then we also have information on the sum total for each and every activity. Okay. And as I'm trying to think of a process improvement project, I might want to try and figure out, is there a way we can possibly reduce the time or reduce the distance that these patients have to move? Okay. So it's a useful tool that a business might want to, or a process improvement team might want to engage. Okay. All right. So let's look at some data analysis tools, and then we will maybe call it a day with regards to this video. Okay. We have different data analysis tools, from checklists to bar charts and histograms to Pareto charts, scatter diagrams, cause and effect diagrams, and graphs. Let's go into some of these and see how you'd go about using this. Now, I have to mention in this phase that I will typically test you on these data analysis tools. So please make time, make sure you understand what each tool looks like, how it would be used, and possibly how you'd put it together. Okay. All right, so let's start off with the most basic of charts that you might get. Okay, a bar chart. Example 2 in the textbook reads, the manager of a neighborhood restaurant is concerned about the smaller number of customers patronizing his eatery. Complaints have been rising, and he would like to find out what issues to address and present the findings in a way his employees can understand. The manager surveyed his customers over several weeks, collected the following data. Okay. So he had complaints from different customers. How many customers complained about the different issues are provided to you here. And I might want to visualize this information. So let me visualize this. Let me transfer this to an Excel spreadsheet, because I can then explain 2 different things that could be done to try and better understand your data. Okay. All right, so we have our complaints, we have the frequency of complaints, and the most basic visualization that I could have would just be through a bar chart here, right? So I could go to insert and just throw in a bar chart, okay? And this now tells me, let me make this slightly bigger. I can almost immediately see that the vast majority of customers complained about the slow service. Okay. Followed by the fact that the tables were cramped. Let me make this slightly bigger. Okay. So this is your basic bar chart. It gives you very basic information, and you could use this information without a doubt. Okay. There's a different type of bar chart that I prefer, and that bar chart is called a Pareto chart. Okay. Now, Pareto chart is slightly different from a bar chart because in addition to just showing us which category had the highest number of people, it actually quantifies it in percentage terms and enables us to focus on what issues are largest by sorting them from largest to smallest. Okay. Now, in Excel, if I wanted to put together a Pareto chart, I would, again, go to Insert and look for a Pareto chart, which is a type of a combo chart. Okay. And let's see if I have the one that I need here. Tip, tip, tip. Nope, I don't see that. So let's try it again. I'm used to using my PC instead of a MacBook, so this might not work as well as I would want it to work. Okay. Since I'm on a MacBook, I might have to create a second column and call this cumulative frequency. Okay. And I am going to here just add each complaint to the next and I have my what's called my cumulative frequency column. So I'm going to add the frequency for the discourteous servers to that of slow service. And then I'm going to add all that to cold dinners, and then add all that to cramp tables, and then add that to the atmosphere. Okay. And once I have this data, I can use this data to create what I call a percentage cumulative frequency column. Okay. And these are the two columns that I'm going to need. Okay. My cumulative frequency, percentage cumulative frequency is going to be this value here multiplied by the total number of complaints. Okay. I can see here we had 89 complaints. So for discourteous servers, this would equal 12 people complained about this divided by 89 total. Okay. And I typically want to see this as a percentage. Okay. Now with that in mind, I can drag this to the bottom. And now I have all the information I need to create a Pareto chart. Let's graph this again. Insert. Let's go to recommended charts because it should be here. Okay. Now I don't see a Pareto chart because I skipped a step. Okay. So I'm going to backtrack just a little bit. I'm going to sort my data, custom sort, and I'm going to sort by complaints from largest to smallest. No, sort by frequency from largest to smallest. And now we can go ahead and graph this. Okay, so this is called a Pareto chart. And a Pareto chart is based off of a principle by an Italian named Vilfredo Pareto, who came up with this 80-20 concept where it's kind of like 80% of the issues you're faced with as, say, a business stems from maybe 20% of the sources of the problems that you have, right? So if I know this 20% and I can target this 20%, then I could potentially resolve 80% of the complaints that the customers are complaining about, okay? So let's utilize that principle here. Let's look at adding, let me add some data labels here. Okay. So we had 42 people complain about slow service. We had 20 people complain about cramped tables and 12 people complain about discourteous service and so on and so forth. Now, this line that you see here changes that into a cumulative percentage frequency. And it gives me a slightly different perspective on my data, and I'll explain that right now. Okay. Now let's look at just the first two categories of complaints, slow service and cramped tables. Okay. If this restaurant is able to tackle the slow service problem and the cramped table problem, they will resolve a total of 70% right here. 70% of all the issues that the customers have talked about are captured by just these two different components, two different complaints, right? So rather than trying to tackle everything at the same time, why can't the restaurant just focus on, first of all, resolving these first two so that our customer complaints drop very drastically, okay? And after that, if we have additional resources, maybe we can tackle the next few complaints that the customers had, okay? So that is your Pareto chart. It's a type of bar graph, which typically is pretty useful. Okay, gives you slightly more information than what you'd have with just a bar chart. Okay, now some other tool that we might have in process improvement. The diagram that you're seeing here is called an Ishikawa diagram, after the person who first put forth this approach. Okay, it's also called a fishbone diagram because it kind of like looks like a fish with a head on one side and the different bones of the fish, as well as kind of like the backbone or the center bone of the fish in the middle. Okay, it's also called a cause and effect diagram. Okay, because it has at the end over here what's called an effect, and it has on the different branches here, the different fish bones you see here, the different causes that might be leading to a given problem. Okay. Now, this cause and effect diagram is typically used in situations where we're trying to drill down to what's actually causing an issue to happen. Okay. So, for example, this manufacturing company says they have a problem with inadequate header production. Okay. And they believe that this problem could be addressed by trying to figure out some cause that might stem from either management or manpower or the methodology used or measurement or the machine used or the materials. Okay. Now, once they've brainstormed those 5 potential areas of causes, for each and every one of these, they're going to drill further down and try and figure out, if you say management might be an issue, what about management is an issue? Okay, so I see here, well, there's frequent changes in header priority. That could be a problem. Secondly, with management, the information is not clearly communicated from the header cell to management. That too could be a problem. Okay. With regards to manpower, it could be that operators are not given specific job requirements, and also that the operators take breaks at the same time. So things like that. Okay. And this helps us to get a better idea of what could actually be driving the issue at hand here, which again is inadequate header production. Okay. So it's a very useful tool for trying to visualize and trying to figure out how to drill down to the root cause of the problem that is being experienced. Okay. So those are some of the tools that could be used when we are trying to improve a process. Okay. So I just thought to share this, and I would ask that you please read the course e-textbook. I have noticed from previous classes that students don't often use the textbook as a resource as much as they should, and it has a lot of really great information. Okay. All right, I'm going to stop there. Hope this helps. Have a good day.